Let's say welcome to Christian Heitzmann.
Here I am.
Yeah, stage is yours.
Thank you so much. So welcome to my talk, Secure Programming in Java. Thank you for coming. You will find the slides I will show you here tonight in the late evening at this link, but you do not take out your cell phones at the moment. I will also show you this link at the very end again, and then you can take a picture of this link at the very end. So, first about you, I expect you, the target audience, that most of you are professional Java developers. That's why I assume, or at least you have to do with Java, either professionally or non-professionally. In this talk, I will focus on core Java Standard Edition and its API. I will talk about secure coding principles and the opposite, its anti-patterns. And I will talk about organizational measures at the very end, which will help you do secure programming in Java. This talk will not be about any security issues in third-party modules. So I won't talk about Log4j, I won't talk about Spring, I won't talk about Jackson or any other frameworks. This talk will not be about cryptography. So I won't talk about SSL, TLS, ciphers, key management, etc. And this talk will not be about infrastructure and DevOps security, which is again another topic. So I won't say anything about build pipelines, containerization, secret management, etc. So you know now the focus of the talk. And 2 words about me. I'm a certified software developer, Java and Python certified. My first language actually is Java. I've been doing Java for more than 20 years, and about 5 years ago I started with Python, which is a complete different world. With my little company in Switzerland, I also do software training. So I'm a trainer for software development techniques. And when you combine these two, I call myself a technical writer. So I'm one of the few people who love documentation, and I also give a lot of talks about software documentation and also write a lot of articles about software documentation, which you can find on my website. This is me. This is my name. And since here in Bulgaria you have other letters, you have the Cyrillic alphabet, this is my name spelled in Cyrillic. So, first of all, let's talk about Java itself. And Java by itself, and this is the message of the talk I will give you several times. Java by itself is pretty safe, mostly thanks to the Java virtual machine. So this includes Kotlin and Scala, etc. The Java virtual machine provides bytecode verification. So it's not possible that data blocks are executed as code. This happens in languages like C or C++, but it does not happen in Java. Fortunately, we do not have pointer arithmetic in Java, which I'm very happy about. Hopefully there are no C++ developers in here. I'm very happy that we have array bound checks at runtime, so it's not possible that you go over the border of arrays. The Java virtual machine prevents incompatible type conversions, so either at compile time, that's what the IDE tells you, you're not allowed to do this type conversion, and if this doesn't work, it tells you at runtime, the latest, that you are not allowed to convert these types. Again, something which C++ does not do. You do not need to, and you do not have the ability to do memory allocation or deallocation. There's no need and no possibility to do so in Java. Memory management is usually done by the garbage collector, which is also a very great invention, I think, and I love garbage collectors. There was also a thing called the security manager. It was quite from the very beginnings, but it has been deprecated since Java 17. And, oops, excuse me. And I will tell you why. The security manager actually has barely been used by people. And it was very complicated to configure it. And then the risk was too high that Actually, it was misconfigured, so it was the opposite of what it should have done, the security manager. That was the reason why they decided to kick it out. Also, people today will use different measurements. For example, you are probably all familiar with sandboxing. So today we secure our applications by putting them into containers or running them on virtual machines. With Java 9, there was the project Jigsaw, so the module system, which also helped you to get stronger encapsulation. You can run your JVM processes with least privileges, which again adds another layer of security for your operating system. Typical security tasks you do not and you should not re-implement, so do not reinvent the wheel. You can use security frameworks. For example, Spring Security is one of such frameworks, which does a lot of security-related things which you do not need to invent on your own again. And people become more and more aware of secure coding practices, and they hopefully avoid anti-patterns, and this is what my talk will also be about, of course. So great that you are here. Now, first of all, let's talk about security risks, and I have a question for you. You will see two different pictures, and you tell me what realistically is more threat for your Java application. Is it number one, that guy? He looks quite malicious. Let's call him hacker. He doesn't look very nice. Or is it these people? They look like users and or software developers. So who do you think which of these two is realistically more of a problem? This one, exactly. So first of all, think of ordinary users and developers you need to guard against. So a very good book is the book Release It from Michael Nygaard. I don't know how to pronounce his last name. In the book Release It, and he has one chapter, chapter 4, about stability, anti-patterns, where he talks about security or stability in general, and he mentions 4 points regarding users and developers with respect to stability or security. Number 1, be aware that users consume memory. So when your application starts running out of memory because it has to serve several users or because users do things which you did not expect, your application will or might behave totally differently than what you were used during development stage. Also expect that users do weird random things. They will do things you never thought of about, and they will find every way to find, they will do everything unconsciously to find bugs in your application, as you probably might already have noticed. And yes, there are malicious users out there. So the hacker you saw on the left side, these people exist. They are not many, but of course they do exist. And users might gang up on you. So imagine you implemented a web service just for fun a little bit, where other people can do something on your web service, and then Taylor Swift makes a Twitter post and she says, hey, I found this cool web service which does this and that, go try it out. And then she posts your URL, and then from one day to the other you have 1 billion users. This is perfect for a marketing perspective, but it's pretty bad on a technical perspective because it will definitely kill your server. So be prepared for spikes regarding user traffic. Another book, which I do not recommend it, I just found this in this book, is the book Code Graph from Pete Goodliff. And it's the disadvantage is it's a very old book. It's from 2006, so there is no new edition of it. This book is actually kind of a clean code book, and this book is significantly better than the book from our well-known Uncle Bob. So the clean code book from Uncle Bob, I personally think, is one of the worst books I've ever read, because it's a pretty dogmatic book and it's just not realistic what he's writing. So this book is definitely better with respect to clean code. And he also has one chapter talking about security. It's called an insecurity complex, where he lists and talks about many other things, and where he lists language-independent risks. For example, hardware theft, so be aware of it. If people get access to your cell phone or to your laptop, they have access to your data if you don't encrypt it. Be aware of man-in-the-middle attack, so be careful what you send over the network wire or over Wi-Fi. Malicious authorized users are also a problem. So these are the employees at companies that have the rights to do something, but they don't have nice intentions. There are a lot of careless users. So these are the people at companies who do not lock their computer, for example, or who open every email, who do not care what websites they open on their website. So they also exist. Social engineering is a pretty effective way to get access to systems, or at least to find out about other people. You will be surprised how much information you get from if you just do a little research on the internet and combine different social media platforms and link them together. If your company has lax permissions, this might be a problem. Malware, of course, you know what it is. We don't need to talk about it. And unencrypted data. So hopefully you do not have data lying around on your hard disk or your flash drive, which is sensitive but unencrypted. So hard disks should definitely be encrypted today. No exception. Also be aware of the difference between attackers and you as software developers. Attackers, so these are now the bad guys. Attackers usually have tools, knowledge, skills, and in particular they have time to get into your system to steal your data. Developers, on the other side, they have things like budgets, deadlines, shortcuts, and a lot of excuses. Yes, I know we should implement some security guards into our project, but we are already behind deadline, so this would cost us another 2 weeks. Let's do it later. Later means never. So you know the excuses. By the way, it's the same excuses that you use when it's about software documentation, which, by the way, gets its own chapter. A must-read, so the source number one when you want to learn about secure coding for Java Standard Edition is the Oracle Secure Coding Guidelines for Java SE. It is updated on a regular basis, so this version is from 2024, the version 10. It contains at the moment 78 guidelines divided into 10 categories. It's one very large web page. By the way, here you find the link in the footnote. Once you have the slides, you also have the link. If you read it in one run, it will take you about 2.5 to 3 hours. So that's a very bad idea to do so. I personally love random numbers or random things. So I personally suggest get them in random order and study 3 random topics every day. So you can concentrate. It will cost you 10 to 15 minutes every day. This will then cost you, in total, it will last for 1 month until you got all the 78 guidelines. And then they do not become boring. You can concentrate on it, and then you can remember them. That's what I definitely suggest. And it starts with the very first paragraph, which is the message, perfect message. So Java's architecture and components include security mechanisms that can help to protect against hostile, misbehaving, or unsafe code. That's what we saw at the beginning. Now important, however, following secure coding best practices is still necessary to avoid bugs that could weaken security and even inadvertently open the very holes that Java security features were intended to protect against. So to summarize, Java by itself is safe, is secure, but you, or we, I'm also a developer, but we as developer can make it unsafe if we do not care of secure coding practices. So what are these best coding practices? First of all, use the best practices of modern object-oriented programming. They have a reason why they are there. I think OO programming has been one of the best inventions during the last decades. I started programming with BASIC when I was a little kid. Actually, I'm older than I look like. That was in the early 90s. And in BASIC, everything is open. You have global variables and you can jump everywhere, so this is just horrible. By the way, Python is also open, so they don't have private access modifiers and so on. That's the philosophy of Python, that everything is open, which I personally do not like in this respect. So when you do OO programming, please do encapsulation. Use access modifiers, put the things into methods, into classes, and lock it down. Things that other people and other developers should not see should be encapsulated. Avoid code duplication, but here be careful. So Uncle Bob, the clean code guy, stated you should not write everything twice. That's why he likes the single line methods, which is totally the opposite of what he wants to achieve. I personally don't like dry. Dry means don't repeat yourself. I'm not a friend of this paradigm. I actually prefer this one here, wet, which is the opposite of dry. And wet means write everything twice. So if you have to write code twice, this can still be regarded as okay. You don't need to do abstract layers and whatever to prevent yourself from copying code. But if you find yourself writing code, the same piece of code 3 times, then you can start extracting it and do some layers around it. So remember the number 3. This is what I would say is the minimum. Have a clean separation of interfaces. Only expose things as interfaces that are relevant to others. Other things do not have to be exposed as interfaces. Minimize visibility. There's a reason why there is a private access modifier. Limit constructor accessibility. Note that you can also make constructors private, which means other people cannot call them from outside, which might be a good thing. And restrict unintended subclassing. So the default for classes should be that they are final or at least sealed. Only make classes non-final when they are explicitly made for subclassing. And I guess that most classes are not intended to be subclassed. So final classes or sealed classes should be the default. Look for fail-fast approaches. I'm currently working at a project with a product that does not have fail-fast approaches. It starts up, it reads the config files, and 500 steps later, you will get a weird error or a weird error message, and you have no idea what was going on, and then you do debugging and reading log files, etc., until you find out, oh, there was a semicolon missing at the config file. Why didn't it tell me at the very beginning? So do fail-fast approaches, check arguments as soon as possible. So actually, I think that every public method should do parameter checking at the very beginning before it continues its actually work. Prefer immutable over mutable classes. I guess you know what the difference is. For example, the old date class is a mutable class, which is dangerous because it only keeps the reference and then it can change its internal behavior or data. And when you compare it to the new datetime API, for example, then you see that modern OO style is favoring immutable classes, which has a lot of advantages. If you cannot have immutable classes, create defensive copies for inputs and outputs so that you as a class can store the state and not someone from outside can change the internal state of your class. When it comes to input, be aware that there might be some file formats that can have an excessive resource usage. For example, when you allow people to give you scalable vector graphics and you want to convert them to raster graphics, If they have high dimensions, it will be very, very large raster graphics, which you did not think of. The same with BMP, the bitmap format, where you can just manipulate the file and then you have extremely large bitmaps. And you just need to change the number of the height and the width. People could give you zip bombs. These are zip files that actually take an infinite amount of memory in order to be extracted. XML entities could be manipulated, hash tables could be manipulated, or regular expressions. So people could give you regular expressions which take an infinite amount of time to execute them or to interpret them. So be aware of it. That means validate the input, limit the resource usage, or escape special characters or sequences, especially when there might be the risk of injecting URLs, or if you want to use the text and put it into an SQL script, which you shouldn't do, by the way. Or for zip files, people could manipulate the path segments and they could name a file ... which actually means that it's now jumping up one hierarchy up in your file system, and then people can access your file system, kind of. So also be aware of this. Definitely do not use Java serialization and deserialization. So do not use object input stream and object output stream. It has been a pain since the very beginning. So since the 90s, 1995 or some years later when it was introduced to Java, it has always been a very high security risk. So when you need to serialize something, use formats like JSON, which are much safer. Also think of throttling input rate, so do not immediately answer if somebody contacts you, somebody contacts your method. Throttle input rates, because every time your function gets called, you probably log it, and when people do this million or billion times, then you will fill up your hard disk with logs, or it might even lead to a denial of service. So just be aware of it. Now we discussed input, let's talk about the opposite, which is output. For legal reasons, you are here in the European Union, so you know the rules, the data protection, whatever. GDPR, I think it's called. You are not allowed to store any personal data or insurance numbers, etc., or even passwords in log files. So be careful about this. Also make sure when you have very sensitive things that you clean memory afterwards, because there could be malware that reads your memory. For example, if you want to read a password on the console, you hopefully are aware of the method read password, which gives you a prompt and you do not see the letters that you are typing in, which of course you should not see when you type in a password. And in the Java API, Javadoc API, you see a security node. If an application needs to read a password or other secure data, it should use read password, blah, 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 and manually zero the return character array after processing to minimize the lifetime of sensitive data and memory. So after you read the password from the user and you compared it with the password if they are same, or even better if the hashes of the two are the same, then manually delete the password by nulling this array. So by putting zeros or nulls into this array again. Also, exceptions and stack traces could contain data which you do not want to expose. Be aware, since Java 15, the flag which is called show code details in exception messages has been set to true by default. This is actually so far a nice thing, because CHAP 358 introduced helpful null pointer exceptions. And perhaps you might have noticed during the last years that now your null pointer exception show you which exactly the problem was, especially when you link several commands, or when you link methods, and then it shows you which of these methods in the chain was the problem, so which object has been null, which is actually a good thing. But when you expose this null pointer exception to the outside, then people can read things that they should not see. And this is not theory, this is a realistic example. So this happened to me in Switzerland 3 weeks ago. So you know Switzerland has a lot of banks, and I have a bank account at the Swiss largest bank, which by the way became even bigger 1 year ago because the second largest bank went bankrupt. So they got it. So this is called the UBS, and I did some online banking on a Sunday afternoon. I did not think anything serious when suddenly my web browser gave me this exception stack trace. I blurred most of it, but this is a screenshot from my web browser. Now I zoom in, and I just want to show you what kind of information you can get by just looking at a stack trace. So when you live in Switzerland and you are into IT, you know the big companies. So I can see at the very first line it says ch.adnovum. Adnovum is an IT company. So I know I already got the information, okay, the e-banking system of the Swiss largest bank has at least in parts been implemented by the company Adnovum. And then you read through it and then you see, okay, obviously they use Apache Jasper and they use Apache Catalina and Apache Struts. I'm not into these modules too much, but if people are, and if they are aware of some modern latest security hole, this might actually be a perfect target. Oh, they use Catalina. I'm aware of a recent bug in Catalina and give it a try and shoot at them. So this is security holes presented on a silver plate. This is just absolutely stupid. I wrote a LinkedIn post about it, and UBS were tagged and Adnovum were tagged, but as I could imagine, there was no reply from them, which is pretty sad. So how could you do it better? By the way, I think you should not write large exception messages because I think people don't read them and it's just work you put into it without having any benefit. Again, I told you already, I love random things. So a few years ago, I wrote an article about using random IDs in software development and everyday life. You can find the English translation at this link here. And I seriously suggest don't write speaking exceptions. Just get a random ID and put it as the exception message. For example, exception code WR7U. And when you as a developer see this exception message, you can just do a full text search in your repository, look for WR7U, and bam, you immediately find the spot where this exception has been thrown. Do you know static code analysis tools? I hope you do. So a very popular one is SonarCube. I'm not advertising it. I just use it and I like it. It checks your code for clean code and other things. I guess you know it, who knows SonarLint, SonarCube, etc. Several people. Perfect. Okay. It also has about nearly 100 security-related rules. They are divided into vulnerabilities and security hotspots. Actually, don't ask me what the difference is. You could read all the rules on their website here. And I just gave you 6 examples here. So the rules, for example, are XML or JSON operations should not be vulnerable to injection attacks. It will spot it in your source code. Extracting archives should not lead to slip vulnerabilities. Secure random number generators should not output predictable values. So when you have a secure random generator, but you give it a constant seed, then it's no longer secure, and SonarCube will tell you so. It will also spot hard-coded secrets or hard-coded IP addresses in your source code and tell you, you shouldn't do this. It will tell you that user enumeration is not a nice thing, and it will tell you that delivering code in production with debug features activated is also security sensitive. By the way, this e-banking example I showed you, that was such an example. So they had their debug mode on and they sent exception messages to the users, which is an absolute no-go. SonarQube is not the only tool. SonarQube is a nice one-size-fits-all tool, but there are also specialized steady code analysis tools. If you just Google them or ask ChatGPT, then you will get the name of the products that are focused on security, if you want to have a separate tool for it. And if you think that these 100 rules are not enough. So I would say this is a good start, and when you follow all these 100 rules, then you can go on with another tool. So I hope that you do know this book, which I also think is a must-read for every Java developer, Joshua Bloch, Effective Java. And I looked through all his items. I read this book many, many years ago, several times. And he has 3 items which have some security aspects in it. And the blue ones I will tell you on the following slides. So enforce the singleton property with a private constructor or an enum type. You will see in a second. Avoid finalizers and cleaners. By the way, finalizers have been deprecated since Java 9. And they have been marked for removal since Java 18. So they will someday be kicked out. Favor composition over inheritance. That's a nice OO rule you should keep in mind. Inheritance is usually, should not be the first choice. I will show you soon. Make defensive copies where needed. We talked about mutable, immutable classes. And prefer alternatives to Java serialization. Don't use Java serialization. It's very, very unsafe. So enforce the singleton property. I gave you 2 examples here. This is a typical singleton. There must be only one Elvis in this world. So let's make a singleton class Elvis, and here we have the public instance, which is constructed once, and we make the constructor private, so people cannot construct a second Elvis. Looks like a nice singleton, right? But the problem is using reflection, or today I saw a talk about doing class file manipulation. I think I saw him even here. Yeah, I think I saw him. So you could do some bad things also. In other words, with reflection, you could also call this private constructor, and then suddenly you can create more Elvises, which goes against the idea of singletons. Perhaps you might not know, but an enum is a perfect singleton, and it's even a better singleton because it's enforced by the Java virtual machine. So you cannot even trick it with reflection or so. This is guaranteed by the Java virtual machine that there is only one Elvis. So this is the instance, this is the one and single enum value, and that's it. It's a perfect singleton. And talking about the other items, which was make defensive copies when needed, I have an example here, which is called time of check, time of use, Tok-Tour attack. It's not Hawk-Tour, sondern Tok-Tour attack. And here you see a bad example. So imagine we use the date, which by itself is a bad idea, but let's go back one decade. And you want to program your own period class, so the distance between 2 dates. So you have a constructor, you accept 2 dates, and first of all you want to check if the start is after the end, because if the start is after the end, that's an illegal period, which doesn't make sense. So we say, you shouldn't do this. And once we checked the start and the end, we save the date as a copy as fields. This is a record, so that's why you do not see start and end, but they are implicitly there in here. So this one says that our record has a start and end field. Now the problem is that there is a bug. Because, read the section title, time of check, time of use. When this check is here and says, okay, it's fine, start is before end, and then another thread changes one of the date objects before this line has executed, then it was possible to get invalid periods into your period class. So what can you do against it? Just switch the order. First, we create our defensive copy, store them as our attributes, and afterwards we check if our copies of the date actually fulfill the requirement that we expect. But it only says medium, so again, there's another bug in there. You do not see it because it's not written. It's a record, and record has implicit getters. Well, they are not called getters. So there are public functions, they are called start and end. And when you call start, you get a reference to the start field. And when you call end, you get a reference to the end field. And when you have a reference to the field, you can change the values afterwards. So you also need to do defensive copies of the output. So we override the start and end getter methods, and we only return a copy. Oh, that's a mistake. This would be end. We only return a copy of the fields that we are storing in our period class. So I have questions to you. You're all Java developers. Have you ever manually configured, which means clicking, a system, for example, a Windows server, Jenkins pipeline, AWS console, any IDE for your project, which took you several hours, days, or even weeks? Have you done so? Then please raise your arm. There should be more. You're professional Java developers. So I assume that nearly everyone should have done this, right? Have you ever written an extensive configuration script, build script, or setup script? Yeah, let's say the extensive, let's say more than one screen page? Yes, okay. Have you ever created a disk image so others could clone it in the future? For example, this is a disk. Hey, I have a Windows system here. What's the current version? Windows 10, 11, I don't know. And I set up everything for you. You are the new employee. So here, take this disk image, clone it, and then you're ready to go. You can start your work. Have you ever created such a thing? Not so many, but some of you have. Now you see the questions which were not there in gray. Could you recreate that system or script or image on a bare system? I give you a bare computer, empty hard disk, and I tell you, please reconstruct the state such that it looks exactly like the disk image you had. Or please configure the Windows server such that it looks exactly like the working one you did last week. Could you do this? No arms. Oh. Then I don't even need to ask the other questions. Have you documented every step it took you to get there? One arm. We will be friends. So, have you explained the whys behind each step? Well, if you don't have documentation, you also did not explain the whys behind each step. We all know the excuses when it comes to documentation. Number one, we are agile. No, you are not. You are stupid, because agile does not mean no documentation. It has never been written or said anywhere by the inventors of agile. It's just plain wrong. Number two, we have no time, we don't have money. I could give you a separate talk about the calculation. We could do the math, and I could show you how much money and time you save in the middle and long run when you do proper documentation. Just think of the people who come after you. Think of new team members, think of new employees. And now it's the favorite one. The code is the documentation. Nope. Code can just self-explanatory code is only self-explanatory to the person who wrote it. It's never self-explanatory to people who did not write it. Even if it was self-explanatory, it would describe a brick, but it would not describe the houses or the house built from these bricks. So a house built from bricks, this is what we call architecture. A class which might be self-explanatory perhaps can describe the class, but it doesn't describe our software architecture. If you want to read reasons, undeniable reasons why you should do software documentation, I wrote some articles during the last years and they're also translated into English meanwhile. You can read them here on my blog, or you can read the interview I did last year, a written long interview also about software documentation, which you can find at this link. Now when you talk to people and say we should do software documentation, everyone has a different expectation. So one person says, oh no, I don't like to write code comments. And the other person thinks, oh, I cannot create diagrams. So there are different expectations of what software documentation actually is, which I will tell you. So first of all, you need to be aware who is the audience. This is one parameter. So there are several software documentations out there. You need to be aware who do you want to address, and if you write something for external developers, end users, it's something different than documentation you target towards internal developers or architects, which again is a different language to the stuff you write for product owners or managers. And the other coordinate you need to be aware of is what level of detail do you want to document. Overall software architectures, which are usually done by diagrams and external documents, are something completely different than classes or interfaces or API descriptions, which you usually do in Javadoc. And again, they are totally different to function internals. This is the point where you should use source code comments that only become relevant if someone reads this function or this method at the moment, but they are not relevant to describe a software architecture and so on. If you want to read more about the different levels, a good starting point, you do not have to copy everything, but a good starting point, read about the C4 model by Simon Brown, which gives you some good ideas of what different levels that are. So this is the crash course. I give a lot of talks about software documentation and articles. This is the one slide that gives the crash course. So I skipped this slide, but now I will repeat it. So why do I talk about documentation? Because I'm strongly convinced that insufficient documentation is a severe security risk. First of all, technical. If you do not have an overview of your architecture, if you do not have documentation. I work at several places where people just tell me, yes, there is a database server over there, just change the IP address, blah, blah, blah. Only from hearsay, I know that there are some servers out there, but I never saw a diagram that lists them all up, or they are on Confluence where you do not find them. If you have no overview, you also see no potential for optimization, for security optimization. And I feels like that every week I read in the newspaper about some ransomware attacks, and then it leads to significant downtime for several weeks or even months. I can just laugh about it. People have configured, so these companies have very complicated configured systems. They have no overview of their systems anymore. Of course, they have no backup, and then they have a ransomware attack, and then they are completely lost, which I personally think it's your own fault. And organizational, if you don't have documentation and if the knowledge is only stored in the head of the employees and the employees leave, the knowledge is also gone. So this is insecure. It belongs to this topic. I guess you do not need to say names. just imagine that every company probably has at least one indispensable guy. And this is usually a guy or a woman, doesn't matter which gender, people do not like. And this guy can actually blackmail its supervisors because this guy has some knowledge other people do not have. And of course, this guy doesn't document. And it can do some blackmailing which says like, well, you give me the 5% annual raise every year or I will leave. Or these are these people that can misbehave and they do not have to suffer consequences because they're indispensable. Do you know such guys? Only one. Yes, I guess you all know such people. Okay. And also think of long onboarding and ramp-up times for new team members when you do not have proper documentation because the stuff you need to ask everyone and you need to reconstruct the puzzle on your own, which is just a waste of time and which makes things insecure. So we had this. I strongly suggest that you do setup protocols. This is something I can disclose. This is my personal setup protocol, about 5 to 10% of how I set up a Mac from scratch. I have personal claims. They are a setup and its documentation are only complete when I can fully reconstruct it on a bare system. So I'm not happy with, well, this is my Mac, it's perfectly configured now. I'm only happy when I can reconstruct it on a bare system, which means if I do everything which is written here and it leads me to the exactly same state. Every manual and automated step must have a reason. Well, you do not see it here, but if it becomes more complicated, every step should have a reason and there should be no setup change without a corresponding documentation change. So every time you change something, which definitely will happen, when you change a setting, it has to be written down in the documentation. So I'm perfect in time. I gave you a lot of information, right? Yes. Do we have to keep all this in mind? In theory, yes. In practice, no, because we probably can't. Be aware, not every developer or architect has the time, interest, or expertise to do these security things. Also, there are inconsistencies, awarenesses, and standards, so people have different attitude towards the security topic. And you probably know the diffusion of responsibility. So we're now I'm now talking about your company, and when you expect that all of the 20 developers you have should have equal knowledge about security and should all take care of it, it probably does not work because there is one thing called diffusion of responsibility. It's a proven psychological phenomenon. To summarize it, simple words, if everyone is responsible, no one is. That's why I strongly suggest do a very anti-agile stuff. Go back with this agile stuff, which has been practiced for 15 years, and there have been conferences, articles, and it has been tried over and over and over and over again, but it still doesn't work. Do some steps back. I claim that having few experts in certain areas really leads to more productivity. Here I claim that you should have a few people, 1 to 3 people, who must check every pull request exclusively for security aspects. So always put them on the list and they have to give their check by just looking if it's security relevant or not. You could call these guys or women security reviewer or security manager, or perhaps you could call them securitator, even though I understand that here in Eastern countries you probably have some bad history linked to this word, so you probably shouldn't call it securitator. And if you ever wonder how might such a securitator look like, I once created a picture. He could look like this. So let's summarize. Java has per se little risk of low-level vulnerabilities. It's a difficult word. But poor programming practices can still open security holes. I think I've proven this clearly. Security spans a very wide and varied spectrum. So you saw, oh my God, there are so many things to take care of. Assign security topics to a few experts with mandatory code review duties. And these few guys are the ones that need to learn security and always stay up to date with security topics. And something most people don't tell you, documentation is also essential when it comes to security. Thank you so much for your attention. Here you see the link again. And if you have any questions, please come by. Thank you so much.